students who wanted to tutor that Google Sheet with my Regents class posts today, so they may be reaching out to you. All right, so let me give you the answers to those even questions that you were assigned for today. Number 34, you had to prove that equation that mu is equal to v squared over 2dg. You had to prove that. Hopefully you were able to do that. 35 was in the back. 37 is in the back. 38, the displacement is 83.8 meters. 83.8 meters. And 42, part A, is 16.4 meter per second squared. Part B is 19.6 newtons. Part C is 19.6 newtons. And in part D, if the acceleration is greater than or equal to g divided by mu, then the box will not fall. All right, what do you guys want to go over? Anything at all that you want to go over? 35. All right, let's look at 35. All right, number 35 says that we have a block of mass M1, which is 250 grams. It's at rest on a plane that makes an angle of 30 degrees above the horizontal. The coefficient of kinetic friction between the block and the plane is 0.100. The block is attached to a second block of mass 2, which is 200 grams, hanging freely by a string that passes over a frictionless massless pulley. When the second block has fallen 30.0 centimeters, what is its speed? Okay, you should be starting with free body diagrams for each block. Did you do that? Yeah. Okay, so let's verify that your free body diagrams are correct. Here's the incline with block of mass M1. You should have drawn its weight, pulling it down, a normal force perpendicular to the plane, a tension force going up the plane, and a force of kinetic friction going down the plane. Then if I do block of mass M2, so this is FG1, by the way, I'd have FG2 going down the plane, and I'd have that tension force, same tension force going up the plane. These two tensions have to be the same because the pulley is massless and frictionless, and the string is massless. So the first thing I want to do is recognize that if this is moving in that direction, this is going to move in that direction. So that is the way this is going to accelerate, which means this acceleration is also in that direction. So I'm now going to write Newton's second law equations for each of these. Let's start with the block of mass M2. The net force on block mass 2 would be FG2 minus FT. And that net force would be mass 2 times that acceleration. The weight would be M2G and FT. Notice again, I've got two unknowns. I don't know A or FT. Everything, I'm giving you masses so we can figure other things out. Over here, that free body diagram is going to get redrawn because it's accelerating parallel to the plane, which means I need all the forces parallel and perpendicular to the plane in order to solve this. So I'm going to redraw it. Keeping the normal force, keeping the tension force, keeping the force of friction, because those are already parallel and perpendicular to the incline. The weight is not. So the weight will get resolved into a perpendicular component and a parallel component, which is going down the plane. Okay, with me? Since it's accelerating up the plane, it means that the net force acting on mass 1 would be the tension minus the parallel component of the weight minus the force of kinetic friction. If it's accelerating up the plane, this is larger than the sum of both of those down the plane, because this acceleration is parallel to the plane. Okay, so that's the mass times that acceleration. Actually, mass 1 times A. Okay, so what I want to do in number 35 is figure out the displacement when I have a particular speed, which means I'm really looking for the acceleration. I need the acceleration to define the displacement with kinematics. So what I'm going to do is solve these equations for tension and then set them equal. Eliminate the tension force. It means that the tension force here would equal M2G minus M2A. I bring the tension to the left and the M2A over here. And what I'm going to do is I'm going to take this and plug that into this equation for tension. So M2G minus M2A minus, now let's replace FG parallel. That would be M1G sine of theta. The force of kinetic friction would be mu k times the normal force. And that has to equal M1A. Now, the normal force is going to get replaced. The normal force is going to balance the perpendicular component of weight. So let's replace that. So M2G minus M2A minus M1G sine of theta minus mu k times M1G cosine of theta is equal to M1A. Let me group terms here. So I'm going to get all my acceleration terms on the same side of the equation. So M2G minus M1G sine of theta minus mu k M1G cosine of theta would have to equal M1A, and this M2A is going to come to the other side. So instead of subtracting it, we're going to add it. Which means that to get the acceleration, if I group this, that would be M1 plus M2 in that grouping. And over here, I'm just going to keep that the way it is. M2G minus M1G sine of theta minus mu k M1G cosine theta. So to get the acceleration, I'm just going to divide both sides by M1 plus M2. So that's M2G minus M1G sine of theta minus mu k M1G cosine of theta all over the quantity M1 plus M2. All right, let me go ahead and start plugging in values. They told me that mass 2 is 200 grams, so that's 0.200 kilograms. G is 9.8 meter per second squared. M1 we know is 250 grams, so 0.250 kilograms times 9.8 meter per second squared times the sine of the angle is 30 degrees, minus mu k is 0.100, times mass 1, which is 0.250 kilograms, times G, 9.8 meter per second squared. Whoops, I'm running out of room. Times the cosine of 30 degrees. All of that over the sum of mass 1 and M2. So that's the sum of 0.200 kilograms plus 0.250 kilograms. All right, let's go to the calculator and get the acceleration. 0.2 times 9.8. I'd like you to double check my math when you do this, please. So if you could grab your calculators and work it out. I don't trust my calculator skills lately. I'm getting an acceleration of 1.16 meter per second squared. So now that I have that acceleration, that agrees with what I have on my answer key that I worked out previously. So I'm pretty confident with that answer. That's what you should get as well. Now that I have that acceleration, let's list what I know for kinematics. I know my acceleration. I know my initial velocity, the V0. It starts from rest. I know that it is going to fall 30.0 centimeters. Well, that is 0.300 meters. I'm looking for its final speed. Since I don't have time, I'm going to use final velocity squared is initial velocity squared plus 2a times the displacement. So that final velocity is the square root of the initial velocity squared plus 2a delta x. That's 0. So I'm going to do the square root of 2 times 1.16 meter per second squared times 0.300 meters. And when you do that on your calculator, I believe you get 0.834 meters per second. If I convert that to centimeters per second, that's 83.4 centimeters per second, which is choice A. Make sense? Okay. Any questions on that problem? Any questions on this? You don't understand why I did something? I have to tell you, in my mind as a teacher, when I come around and see that some of you are doing this in maybe this much space total on your page, a quarter of a page, I know you're not doing it right. I know instantly. Each of these questions took me about, you saw how big one problem took me, how much space. And I've been doing this since 1988. There's no way I can work it out in this much space. And I am not writing that big. Yeah, I'm not writing as big as Grace. I'm not right itty bitty. You got to be able to write it in a size that we can read it, but you also have to show your steps, because if you're not showing the steps, you're making mistakes. Do you want to get it right, or do you want to save paper? The two things are not going to happen together. You need to work it out. Let your brain, give yourself grace. Your brain needs to see those steps. None of you is Albert Einstein yet, where you can just see it in your head and it's done. You don't have to write it out. You're not there yet. Okay, Olivia. Yep, let's look at 42. Page 143. Lou is betting against an innocent stranger that he can place a 2-kilogram box against the side of a cart shown in figure 542, and that the box will not fall to the ground, even though Lou will not use any hooks, ropes, fasteners, magnets, glue, or adhesives. When the stranger accepts this bet, Lou begins to push the cart in the direction shown, and the coefficient of static friction between the box and the cart is 0.6. Part A, I want you to find the minimum acceleration for Lou to win the bet. Okay, first thing you should be drawing is a free body diagram for the mass on the front of the cart. There are 3 forces acting on that mass. That blocks weight, pulling it down, a static friction force opposing that weight along the left edge of the block. And then, since there's a surface here on the left side of the mass, that surface pushes out perpendicular to the surface. So, since this is static friction, we know that these 2 forces are going to have to balance, because the mass is not going to move up or down. That means that that force of static friction, if this is not moving, has to balance out the weight. No matter what, that force of static friction has to be mg. Now, on this diagram, what is unbalanced? The normal force. So the net force on this mass is the normal force that's acting. So MA is the normal force. So assuming that we are over here, we know that the static friction force is somewhere between 0 and the maximum static friction value. If I assume that I'm at the maximum static friction value, this would be mu s times Fn. And that Fn would be equal to Ma. So now I can solve for that acceleration, g over mu s. So in part A, that would be 9.8 meter per second squared divided by the coefficient of static friction, which was given as 0.6. So this is going to give me the minimum, because if I have the maximum force, that would give me the minimum acceleration to make that happen. So 9.8 divided by 0.6 gives me an acceleration of 16.3 meters per second squared. It's got to be at least 16.3 meter per second squared. I think I said 16.4. That was when I calculated using 9.81, which we know for the AP exam, we want to use 9.8 instead of 9.81. Okay, so that is your minimum acceleration. In part B, what is the magnitude of the frictional force in this case? The frictional force is equal to the weight. It's got to equal the weight. So in part B, what I'm going to do to find that frictional force is I'm going to calculate the weight. The mass of that block is 2 kilograms. G is 9.8 meter per second squared. So 2 times 9.8 is 19.6 newtons. That's how much it has to be no matter what. The block's not moving. It's got to balance the weight, period. Doesn't matter as long as it's accelerating at that rate. Now, part C, find the force of friction on the box if the acceleration is twice the minimum speed. Doesn't matter. The force of static friction still has to balance the weight, which is 19.6 newtons. As long as you are accelerating at that rate or more, it's not going to move. Makes sense? That's because that friction force is variable. It's a variable amount. So in part D, show that for a box of any mass, the box does not fall. Well, we kind of did that up here. We did that here. Do you see how the mass canceled out? We proved that the mass isn't involved. So this is really comes about from this derivation to help us get part D. Okay. Anything else? All right. So then let's talk about this lab. So when you read the lab and my instructions on the lab in our Google Classroom here, let's get to that lab. Let's just make sure you understand the directions on the lab. And then I'll talk about what you're going to be limited to. So for November 4th, which is Tuesday next week, you have to write your procedure. And then what I will be doing November 4th, 5th, and 5th is grading that right away, reviewing it to make sure it's acceptable. If it's acceptable, I'll print it out. If it's not, then I will send it back to you, say you have to make some changes. I would like only one person per group to do this. One person per group to submit it. Okay. I also need to know when you do that, not in the procedural document itself. You're not going to put your names on the procedure. I need you to add a comment to it when you submit it. Tell me who you're working with, who it's being submitted for. Okay. That way I can assign that grade to everybody in the group. You follow what I'm saying? Okay. So notice I'm telling you that you're going to have 3 or 4 students in a group, and there are 3 parts to this lab. In part 1, you and your group are going to create a procedure which includes an equipment list and diagrams or sketches to show how the lab equipment needs to be set up by the people who are going to do this experiment for you, and how to collect the data. That's what your diagrams or sketches are showing. How do you set up the equipment? How do you want them collecting the data? You're going to write that procedure, including that information. You're also then going to create data tables that they will then, once they are collecting the data as outlined in your procedure, they're going to fill in those data tables for you. Please understand, a procedure never talks about how to do a calculation in the lab. How are you collecting the raw data? That's it. No calculations whatsoever. That will come, the calculations you do with the data will be part of your analysis in part 2. But the people doing your lab are not going to do any calculations for you. They're just going to make the measurements that you ask them to make using the steps you outline. That's it. You follow? Okay. How are you going to write a procedure? What is your goal? Your goal in this lab is to figure out whether the air resistance force acting on some of these basket-style coffee filters is proportional to the speed or speed squared. Remember how we talked about drag forces? That it's v to the nth power. We don't know if n is 1 or 2. And that's what you're trying to figure out as a group. So the equipment you will have access to. And this is all you get. You've got coffee filters. I have about 500 of them over there. Okay, they are each very, very, very thin. So you can tell them how many coffee filters you want them to use. You've got metric measuring tapes, which we've used before. You have meter sticks. I will also give you masking tape. And they will have access to their Chromebook to get a stopwatch. That's it. That's it. Okay? No triple beam balances, no digital scales, no photo gates, that's it. That's all you got. No slow motion cameras to do things. I don't know. I've had students ask me before for other wacky equipment. I'm like, if it's not on that table and it's not your Chromebook stopwatch, you can't use it. That's all they're going to have. You will have to decide as a group how many trials you want done, what equipment you want done, what measurements you want them making, and so on and so forth. Make sure you read the lab handout. It gives you 2 different ways that this can be done. If you don't read it, you're not going to have any clue what to do. I'm checking to make sure that you know how to write a procedure. I want you to think about, there's an exercise that some teachers have done, sometimes at the middle school, about writing procedures. It's like, how do you make a peanut butter and jelly sandwich? Have you ever had to do that? Write the directions to someone to make a peanut butter and jelly sandwich. I've seen things as simple as put the peanut butter and the jelly on the bread. Okay, so I would take a bag of bread and I would take the jar of peanut butter and the jar of jelly and just stick it on top of the package of bread. Does that make the sandwich? You've left out a lot of things. You need to write your procedure like a monkey is doing this for you. Monkeys are very intelligent. Ask Jane Goodall. Chimpanzees. Well, she's passed away this year, so you can't ask her. But that's what she's studied her whole life. Primates. They are very intelligent creatures. Oh, let's make it a human. Pretend you have a 4th grader doing this lab for you. Your classmates are not 4th graders, but for this purpose, they're going to act like 4th graders, not behaviorally. Okay, I don't want you jumping around and running up and down the hallways or whatever. But I want you to write it so a 4th grader could do it. Okay? Maybe I'll call one of my colleagues who's a 4th grade teacher and say, hey, we're going to have the kids do a lab. Let's see how they do. Not how well the kids do, but how well you can write directions for a 4th grader. And keep in mind that a 4th grader's vocabulary is very low, right, compared to yours. So sometimes directions are not, have you ever purchased some ready to assemble furniture? Comes in a box, all these pieces. You get a bag of all the screws and so forth. And then you read the directions. How many words are in the directions? Sometimes none. Why do they do that? What are in the directions? Lots of pictures showing what needs to be done. You want somebody to do it a certain way and set it up a certain way? Guess what? Make a picture showing them what to do. Then you don't have to write words. Yeah.
Do you have to sketch pictures or
You can take pictures with your Chromebook. I wish I could say you could use your phone, but you can't. You have to use your Chromebook to take photos, which you could do. You certainly could do it. So we have the rest of today, and we have all class period tomorrow for you to work on these things. And I'll have that equipment out, but that's it. After that, if it's not done, then obviously you and your group are going to have to work outside of class to get it done and turned in before period 4 on Tuesday. That way I have Tuesday and Wednesday to review your procedures and get them back to you. On Thursday, that's the day you're going to be collecting the data for another group. Okay. Any questions for me? All right, so you want to get started? All right, so obviously you have to brainstorm with your group to figure out how you want to do this. I don't know that you want to take pictures today. Tomorrow may be the day to take pictures if you want to take pictures. But I'm leaving all that stuff over there for you guys to use. Remember, this is a procedure. Do not tell them how to analyze your data or calculate anything. Just how do you want them to get the data? And have the data tables there for them to fill in.